So what I want to do now is I actually want to investigate the default change detection mechanism. So I'm going to change, in our example, I'm going to change the change detection strategy to default. And we're going to inspect it a little bit. We're going to play, investigate it by playing a little bit with the change detection. So if we look back at the application with the automatic change detection, with the default, I remind you that we see that the display is updated after every change. And we now understand how it works. We understand that it works because whenever the set interval sets the interval to change the counter, we're actually running not the original set interval, but the modified one, the one Zone.js created for us. And Zone.js alerts Angular, and it allows Angular to respond by running the change detector. And in that case, we do not need to inject the change detector ref, and we definitely don't need to call it. So I'm going to put these on comment. Now, I do want to show you what I mean when I say that Angular evaluates binding expression. Now, as you know, I can create binding expressions which are not just constants or properties. We can actually call functions. It's highly unrecommended, and you will see why in a second. So let's create a function and call it calculate value, and we will have our function just return 42. And now let's display it here. So h2 the calculated value is, and we'll call calculate value. Now when we go to the application, you can see that it displays 42. And I'm going to do something a little bit more than that. So what I want to do is I'm going to go to the calculate value function and print something to the console. And the reason I do it is because I want us to see whenever the expression is evaluated. Okay, so calculating value. Now, basically, this little experiment allows us to see anytime the change detection mechanism is activated, because every time the change detection mechanism is activated, it will call calculate value again to evaluate the expression, the binding expression. And that means that it's going to evaluate it once, and then it's going to evaluate it again, and it will check if there was any change. And if there is a change, it will display the new value on the DOM. So if we look here, we can see that every time one of the values change, you see, now just look at the time here. You can see this is a cycle. This is one cycle. And you can see that for every cycle, there are two calls to the calculating value. Now, this makes absolute perfect sense because we know that whenever a change detection cycle occurs, it first calls the expression before the function is executed, and then it calls it again after the function is executed, and then it prints it. And then it checks for the differences between them. So that means that for every change detection cycle, the expression is evaluated twice. All right. Now, just imagine that you had not one or two values. Imagine that you have a full-blown application with maybe hundreds of expressions. And by the way, now you understand why it's really not recommended to use functions as binding expressions, because then these functions are re-executed over and over again. And if the function does something that's more than just trivial, then it can cause major hit. Now, I'm going to do another thing just to demonstrate how frequent change detection can be. So you remember the do nothing function, the function that does nothing, right? And you remember the button here that calls it when clicked. I'm going to add another event handler here. I'm going to say, in addition to calling the do nothing function when clicked, I want to call it on mouse move. Okay. Now, look what happens. So you can see the values here. And now I'm going to clean this and just roll over the button a little bit, move the mouse over the button. And you can see that in a matter of 3 seconds, I managed to get 500 messages almost. So that means that the values were evaluated, the expressions were evaluated 500 times in a matter of a few seconds. And again, just imagine that this can happen on a much larger amount of binding expressions. Because if you have a real application, you probably have hundreds of these. And that's why we don't like the automatic change detection. The automatic change detection can cause major performance hits. And we actually prefer to use the push change detection because it causes more refined, more controlled occurrences of change detection. But actually, even moving to push change detection is not enough for the Angular team, because even when we use the on-push change detection, we still trigger change detection for a large portion of the visual tree. Maybe not all of it, because it depends which component causes the on-push, but it still runs change detection for quite a lot of the templates on the tree. And the Angular team was aiming for something that's a little bit more fine-grained. The idea behind signals is that signals, as the name suggests, signal when they change. And when Angular knows not just that it needs to generally run change detection, but it actually knows specifically which expressions changed, it can check for changes and modify the appropriate location in the DOM only for those specific elements that actually changed. When we use the on-push change detection, even when we control when the change detection occurs, it still checks all of the expressions, even the ones that didn't change, because it cannot know which one changed. And with signals, it can actually map the very specific items that changed and modify only them. So what Angular is aiming for is a zoneless application, an application that doesn't use zone at all and that uses fully signal-based expressions, so that every time something changes, it will be easier for Angular, it will be possible for Angular to modify only the bits that actually changed. And that will improve significantly the performance of the application.